I think that there is a bit of David Attenborough in all of us, and for me, it's what makes the study of bacteria so fascinating, their different mechanisms for survival and abilities to adapt to stress. I'd like to focus on one particularly special group of bacteria called Mycobacteria. Special because they have adopted a very different strategy for survival compared with most other bacteria. These are tortoises in a world of hares. Whereas most bacteria divide every 20 to 30 minutes, so that after an hour you already have 8 children, or after a day upwards of 60,000 offspring, Mycobacteria will perhaps divide just once or twice in a whole day. What prize can be worth paying such a huge price for? The answer is, like the tortoise, virtual indestructibility. These organisms expend much energy on constructing envelopes that are immensely resilient to the outside world, which means that they not only do occupy some of the most inhospitable ecological niches, but are also, unfortunately for us, incredibly resistant to both human defense systems and antibiotics. 2 species within this group you may have already heard about, tuberculosis and leprosy, but increasingly some of the other so-called non-tuberculous mycobacteria are causing very serious human disease. And there is one such that is the most problematic, Mycobacterium abscessus, causing both severe disfiguring abscesses that usually require surgery to achieve cure, but also progressive lung infections, most commonly in those with cystic fibrosis or chronic lung scarring, something that we may unfortunately see much more of now after COVID. The reason our research project is focusing on Mycobacterium abscessus is threefold. Infection rates are increasing, it is virtually incurable by medicines alone, and because we have major problems in the laboratory using traditional methods to work out which antibiotics are effective against a patient's strain. The tests just don't work. But very recently a new lab model has been developed called the Hollow-Fibre system that allows continuous titration of the concentration of drugs surrounding the study bacteria using calibrated flow instead of static test tubes, in a way that much more accurately reflects what's happening in our bodies at a cellular level. Also, and this is critically important for mycobacterial work, it allows different drugs to be put together to work out which combinations and in what doses work best. So our group will be amongst the first in the world to use this new and incredibly powerful tool to test out the most promising new drugs against clinical strains of abscessus taken from our patients. And we hope that this will lead directly to improvements in our ability to provide treatment and care for this group of patients.